Every AI agent you've ever built forgets everything the moment a session ends. Every single one. You give it tools, you give it prompts, you give it a goal, and then it finishes, restarts, and has absolutely no idea what it just did. That's not a minor inconvenience. That's a fundamental architectural flaw. And the fix turned out to be 3 plain text files. Agent Kernel is an open-source project by developer Oguz Bilgic that gives any AI agent persistent memory using nothing but Markdown. No database. No vector store. No framework lock-in. Just 3 files, Agent.md, MEMORY.md, and STATE.md. That's the entire system. Let's talk about what this actually does in practice. Agent.md is the agent's identity file. It defines who the agent is, what its purpose is, what tools it has access to, and how it should behave. Think of it as the Constitution. It doesn't change between runs. MEMORY.md is where things get interesting. This file accumulates knowledge across sessions. Every time the agent learns something worth keeping, a user preference, a fact it discovered, a decision it made, it writes that into MEMORY.md. Next session, it reads that file first. Suddenly the agent remembers your name, your preferences, the last 3 things you asked it to do. It's not magic. It's just a text file being read at the start of every prompt. State.md is the operational log. What is the agent currently working on? What step is it at? What decisions are pending? This file tracks the live mission so that if the agent crashes, restarts, or gets interrupted, it can pick up exactly where it left off. No lost progress. Here's a concrete example. Imagine a research agent tasked with summarizing 10 academic papers. Without Agent Kernel, if it crashes after paper 7, it starts over from paper 1 next run. With Agent Kernel, State.md knows it finished papers 1 through 7. It resumes at paper 8. That alone saves hours on long-running tasks. What surprised me was how little infrastructure this actually requires. You don't need a Postgres database. You don't need Redis. You don't need to learn LangChain's memory abstractions or set up a vector database just to remember a user's name. The entire kernel is readable, editable, and versionable with Git. You can literally open the files and see exactly what your agent remembers. That's a debugging experience most frameworks cannot offer. But here's the thing, this approach has real limits, and they matter. Agent Kernel does not solve multi-agent coordination. If you have 5 agents running in parallel, they all write to their own files, and those files don't talk to each other. There's no built-in conflict resolution, no shared memory bus, no consensus mechanism. For solo agents on focused tasks, this is fine. For swarms, you'd need something more. It also doesn't scale to very long histories. Markdown files grow. If your agent has been running for weeks and MEMORY.md is now 10,000 lines, you're stuffing all of that into a context window on every single call. At some point the file becomes too large to be practical. There's no automatic summarization, no pruning, no retrieval mechanism. You are responsible for keeping these files lean. And there's no built-in security model. These are plain text files on disk. If your agent is handling sensitive data, API keys, personal information, confidential business logic, you need to handle encryption and access control yourself. Agent Kernel doesn't touch that. So where could this realistically go? The most obvious evolution is an automated summarization layer. Instead of MEMORY.md growing forever, a background process periodically condenses it, keeping the most relevant entries, archiving the rest. That would extend the practical lifespan of a single agent dramatically. Another plausible direction is Git native versioning. Since these are text files, you could automatically commit State.md and MEMORY.md after every agent run. That gives you a full audit trail of everything the agent ever did, every decision it ever made. For regulated industries, finance, healthcare, legal, that audit trail isn't a nice-to-have. It's a requirement. You could also imagine a lightweight sync layer that lets multiple agents share a read-only version of MEMORY.md. Not full multi-agent coordination, but enough for a lead agent to broadcast context to worker agents. Simple, transparent, debuggable. If you're deploying this as part of a production pipeline, DigitalOcean's app platform handles persistent file storage cleanly. Your Markdown files survive restarts without you building a custom persistence layer around them. So why does Agent Kernel exist? Because the mainstream solutions are overbuilt for most use cases. Vector databases, embedding pipelines, memory frameworks, they're powerful, but they introduce weeks of setup, vendor dependencies, and abstraction layers that obscure what your agent is actually doing. Most developers building agents for real tasks don't need semantic search over 10 million memories. They need the agent to remember what it did yesterday. Agent Kernel makes that embarrassingly simple, and that simplicity is the point. The project is a direct response to agent amnesia, the frustrating reality that most agents deployed today are stateless by default. Every session is session 1. Agent Kernel treats that as unacceptable and solves it with the most boring technology imaginable, a text file. There's something philosophically honest about that. The best solutions often aren't the most technically impressive. They're the ones that understand the actual problem and refuse to over-engineer the fix. The GitHub link is in the description. The whole system is 3 files, so it takes about 10 minutes to understand fully. Next episode we're looking at an open source project that automatically generates test cases for your AI agent's outputs, which pairs almost perfectly with what you just saw here.